So hello and welcome everyone. Welcome to Kreatryx. Welcome to Unacademy. So in these sessions, we are going to start the communication system and you are going to study the communication system like never before. So before that, let me introduce myself. My name is Vishal Soni and I have cleared ESE examination 2 times, both times in double-digit rank. And I have also served as a Group A gazetted officer in Indian Railways and in Indian Telecommunication Services. And I have also cleared a lot of public sector examinations. So right now I'm teaching on Unacademy and I really feel proud to be the part of the Unacademy team, because Unacademy is the revolution in the field of free education and in the field of affordable education, and we as a team are really looking forward for every student to just come onto the Unacademy platform. You can attend the special classes, you can come onto this YouTube channel and you can stay connected with us so that you can understand the quality education and you can understand the efforts that we are putting in, so that every student of this country, whether he stays in a village or he stays in a town, should get the access of the content, that too in a very affordable prices, and he can also or she can also clear the examination with the best possible ranks. So right now I'm teaching on Unacademy with more than 15 million watch minutes in the overall duration and 2 million watch minutes in the last 30 days. So I am right now the top educator in Unacademy across all the branches, having rank 4 right now. And you can also follow me on Unacademy on this particular link. So you can go and follow me on Unacademy. Apart from that, my advice to every student is that how should you crack the examination and what are the components to cracking the examination. So the first question that comes to the mind, that can anyone prepare from the YouTube? Yes, you can prepare from the YouTube, but you should develop or cultivate some habits in yourself. For example, you should be very much disciplined. You should arrange the extra resources. For example, the PDFs you have to arrange, the test series you have to arrange by yourself, and most importantly, that self-discipline you should be containing in yourself, so that you can be very corrective manner and you can approach the examination in the best possible manner. So all these things you have to arrange yourself. The sense of competitiveness you have to cultivate in yourself, because the audience on the YouTube are not that much of competitive in nature, or maybe you cannot feel the competition which is present right now. So all these things are the part of the journey if you want to prepare through the YouTube, or maybe if you want to prepare through the free resources. Apart from that, if you want that you should get complete content, then this is the YouTube channel. On this YouTube channel itself, all the free content are available. You just have to go to the playlist. All the subjects are completed there. You just have to go and watch all the lectures one by one. Definitely will be getting benefited. But the extra things that I have told you, that the self-discipline and the sense of competitiveness and a lot of things you have to arrange by yourself. If you are comfortable in that, then you can do that. Apart from that, you should also have Unacademy learning app, so that the special classes you can attend. A lot of educators in this country are actually providing the special classes, that too absolutely free of cost, so that you can get the quality content in the best possible manner. Apart from that, there is also another component for you, which is Unacademy Plus. So on Unacademy Plus, what is your job? You just have to study. If you join this Unacademy Plus, you do not have to worry about the crash courses, weekly test, doubt solving sessions, the language barrier, rank improvement batches, live classes. So all these things will be taken care by the Unacademy. You just have to take the Unacademy Plus subscription and you have to come on to the Unacademy. You will be daily getting the live classes. You will be getting the crash courses. When you will be getting the crash courses? When the syllabus are completed. You will be getting the weekly test in the form of quizzes. Every fourth class is the doubt solving session, which is the major you can say the component or the major impact will be creating on your studies will be this doubt solving group. Because until and unless your doubts are not being cleared, until and unless you are not able to clear your doubts, you will never get the confidence in the subject. So once you come on to this Unacademy Plus, every fourth class is doubt solving session. Apart from that, various other doubt solving sessions are going on. So ultimately you will be getting your doubts cleared and you will gain confidence in the subject. The language barrier will not be an issue, because the batches will be running both Hindi and in English, and rank improvement batches will also be there. So all these things are the component of this Plus subscription. Once you come on to this Unacademy Plus, you do not have to be worried about your self-discipline, your competitiveness nature. Everything will be present on Unacademy, because a lot of other students will be there. Since the classes will be live, you can also watch it recorded later on. So the discipline automatically comes, because you get the idea that you will be having the daily live classes. Apart from that, there is also one iconic subscription. In this iconic subscription, the game changer is this personal coach. So this subscription is for them who thinks that their basics are weak, or those who are talented but they needs a continuous push. So this personal coach will be guiding you throughout your study. He will be giving you the study planners. You will be getting the study booster sessions. Once you will get the test, you will be getting the analytics. Analytics plays a major role in improving yourself. We as a teacher also get our analytics so that we can improve on the daily basis. So once you start getting the analytics, you will be also improving massively on the daily basis. Apart from that, there will also be the guidance for the mains once you clear the prelims, and there will also.
Hello friends, so in the last lecture we studied about the quantization and we saw the characteristics of the quantizer. We also saw how to define a uniform as well as non-uniform quantizers. Now in this class we will try to calculate the quantization error power or the quantization noise power. So basically, first of all, we have to understand what is the quantization error or what is the quantization noise. So for that I am giving you a simple example. Suppose you take this quantizer and this is the input x and this is the output x cap. This is the quantizer. Let me call this quantizer's threshold as 2, and suppose x has dynamic range from 0 to 4. So first of all we will draw the vertical diagram. The vertical diagram would look something like this. So it will have 0 to 4. This is the threshold. It will divide the dynamic range into different regions, and this dynamic range will be as a whole mapped to a single point, which is generally the midpoint of the region 0 to 2. Similarly, the region which is from 2 to 4 will also be mapped to a single point, which will be generally the midpoint of the region 2 to 4. So you can say from here that whenever x is lying between 0 to 2, this x cap comes out to be 1, and whenever x cap is lying between 2 to 4, this x cap is coming out to be 3. So suppose I make a table at which I want to indicate these values. So this value is quantizer input, this value is quantizer output. Now here I am defining an error which is known as quantization error, which can be defined as x minus x cap. So you can see from here that if x comes out to be 0.5, 0.5 will come in the region R1, and this region R1 as a whole is mapped to 1. So it will be mapped to 1, and the difference between these two will be minus 0.5. So clearly there is error. The sample value was 0.5 and you mapped it to the 1. So the error comes out to be minus 0.5. Similarly, if I take any value, for example, I am taking any value which is 2.6. So 2.6 will lie in the region R2, it will map it to 3. So the error comes out to be minus 0.4. Or suppose if I have taken a value as 1.7, 1.7 will come in the region R1, so it will map it to 1 and error comes out to be 0.7. So the error can be the difference between the input of the quantizer and the output of the quantizer. So this particular term is known as quantization error. So now onwards, if I have to define the quantization error, I will define the quantization error as x minus x cap, or I can also write it as x minus qx. If x is random variable, x into qx will be random variable. More specifically, if this is continuous random variable, this will be discrete random variable, because continuous range of values is being mapped to a single point. So the quantization error, which is x minus x cap, will also be a continuous random variable. We know that if we have to calculate the power of a random variable, so we generally calculate its mean square value, or it can be written as x minus x cap whole square. And to calculate the quantization error power, you can calculate this following value. So this will represent the quantization error power, and this expression represents PDF of random variable x at the input of the quantizer. So in this manner you can always calculate the quantization error power. So this is the most general formula of the quantization error power. Let us try to discuss it in a little bit detail. So for that I am making this particular diagram. This x of t is the random process. We have sampled it, and output of this random process at any instance comes out to be x. This is our quantizer. So this is the quantizer, and this quantizer has threshold levels as M1, M2, Mi plus 1, Ml plus 1. Now this x has dynamic range from xmin to xmax, and it is also distributed between this xmin to xmax, and the output I am calling it as x cap or q of x. Now these are L threshold levels. So these are L threshold levels. Now what this quantizer will do, it will scan the input which is varying from xmin to xmax, and it will divide this particular dynamic range into L different levels. So this is the dynamic range. I can call this value as xmin and this value as xmax. The xmin should match with M1 and xmax should match with ml plus 1 so that the complete input can be quantized. Now these decision thresholds will divide the dynamic range into different regions. So I am denoting those regions here. This region will have width as delta 1. This region will have width as delta 2. This region will width have delta I, and this region will have width as delta L. And the input which is applied here will be distributed between xmin to xmax. So this input has been applied here, and these threshold levels has divided this range of input into different regions, and now each region as a whole will be mapped onto a single value. So this particular region will be mapped to a single value, and let me call this value as x1 cap. Similarly, this value will be mapped to x2 cap. This value will be mapped to xi cap, and this can be written as xl cap. So the values which is written here, x1 cap, x2 cap, xi cap, xl cap, are also known as quantization levels or points. Sometimes it is also known as representation levels or points, or reconstruction levels or points. From this diagram you can say that whenever x lies between m1 to m2, x cap becomes equal to x1 cap. So this is the input of the quantizer and this is the output of the quantizer. Similarly, if this x lies between m2 to m3, this x cap becomes x2 cap. Similarly, if this x lies between mi to mi plus 1, this x cap becomes xi cap, and if this x lies between ml to ml plus 1, this x cap becomes xl cap. So this is the relation between input and output, and you can say that this range of inputs is being mapped onto a single value. Similarly, here also a range of values is being mapped onto a single point or a single value. Now from this diagram you can also see that if this point is considered to be midpoint, so this will become delta I by 2, this will also become delta I by 2. So from here we can also write that this mi plus 1 minus delta I by 2 will be equal to mi plus 1 minus xi cap will be equal to delta I by 2. Similarly, this mi minus xi cap will become equal to minus delta I by 2. So these are the two relations which you should remember that we will use later on. Now since we know that the random variable x is also distributed between x min to x max, so we can also obtain the PDF of x. So let me draw the PDF of x. This is f(x) of x versus x. So any shape of PDF can be considered. I'm considering this particular shape. We know that the random variable x is taking values from x min to x max. This x min parameter matches exactly with m1 and this x max matches exactly with ml plus 1. These decision thresholds will divide the dynamic range into different regions. So the dynamic range is from this x min to x max, and it will divide this dynamic range into different regions. So I am considering this point as m2, this point as m3, this point as mi, this point as mi plus 1, this point as ml, and finally this point as ml plus 1. So we have divided the PDF into different regions. Now if we observe the horizontal axis then horizontal axis is representing the dynamic range of the random variable x, which is from xmin to xmax, and different decision thresholds of the quantizer has divided this dynamic range into different regions. So from very clearly you can see here that this is the region R1, this is the region R2, this is the region Ri, and this is the region RL. Now the width of this region you can call it as delta 1, width of this region you can call this as delta 2, this can be delta I, this can be delta L. So you can call this region as delta L. So you also obtained the width of each particular region. Now if I have to calculate area of any particular region, then the area I can define it as AI. So this is the area of this particular region. Now we want to obtain different parameters from this particular PDF. So the first point which I want to calculate from this PDF is its area. So whenever I will talk about the PDF, the area of this particular PDF dx, which is from xmin to xmax, and this comes out to be 1. So the area of the PDF comes out to be 1, and it will be always 1 from xmin to xmax. Second important point, suppose we have to calculate the probability that x cap becomes equal to xi cap. We know that this will happen only when x lies between mi to mi plus 1. And since this is a random variable, we can always relate the probability of a random variable to its PDF. So I can write it as the area from mi to mi plus 1 of the PDF fx of x dx. Now if you have to calculate the area of the PDF from mi to mi plus 1, so this is the region from mi to mi plus 1, and this is the amplitude in this particular region. So this is the amplitude in this particular region, obviously which is varying, not constant, so let me call it as fi, and this is the width delta I, and if you will calculate its area, that area I have denoted it as AI. So obviously it will represent the area of ith region in PDF. So the probability that a quantization level occupies a value xi cap will be the area of the ith region. So you can say that the probability that the quantization level becomes x cap equal to xi cap will always be equal to the area of ith region in the PDF of the input random variable at the quantizer. So this is very important relation which you should remember, that whenever you have to calculate the probability that quantizer level becomes some certain x cap equal to xi cap, then you need to calculate the area of the ith region in the PDF, and that PDF must be of the input variable at the quantizer. Now next important thing which you can notice is, if I consider the PDF of x to be uniform. So if I consider PDF of X to be uniform, so you can see that if PDF of X would have been uniform, then the shape of the PDF would have been something like this. So this is fx of X versus X. So in that case, the amplitude of the PDF would have been constant. This is M1 ml plus 1, and this amplitude would have been constant throughout. So in that case, I would have been said that this Fi would have been constant. So whenever the PDF of the X is uniform, then Fi will be constant. We know that the width of the ith region is delta I. So this particular value x cap equal to xi cap, which is the area from mi to mi plus 1, and this area becomes mi to mi plus 1 fx of x dx. It comes out to be ai, and it will be the constant value Fi into delta I, because it will form a rectangular strip. So the area of that rectangular strip will become Fi delta I. Now if I consider PDF of X to be non-uniform, in that case, the probability that x cap equal to xi cap will be the probability that the region is covered from mi to mi plus 1, or you can write it as mi to mi plus 1 fx of x dx. So this is the area of the ith region. Now what I'm saying here is, suppose we are considering this delta I to be as small as possible. So if you will observe the PDF closely, so you can say that in this particular case, this is your x min, this is your x max. Somewhere here we will have this mi plus 1. Obviously this will match with m1, this will match with ml plus 1, and in between we will also have some m2, in between we will also have some ml, and so on. So from here you can say that this is delta I and this is Fi, which is varying. Now in this case it is saying that consider this delta I to be very small. Now if this delta I, which is the width of this region, becomes very small, say for example this much of small. So earlier when delta was varying from here to here, the amplitude was continuously changing from this point to this point, and we cannot consider this as constant. But if delta I becomes very small, the variation of Fi in this small distance will always be very less, and we can assume roughly Fi to be constant. So whenever delta is very small, in that case I can consider the amplitude of the PDF to be constant. So if the amplitude of the PDF is roughly constant, this width becomes delta I, so it will again represent a rectangular strip, and the area can be written as Fi into delta I. So these two are the approximated cases in which you can define the area something like this. So what you can say in this case, that if I have to calculate the probability of x cap equal to xi cap, or the quantization level assumes the value of xi cap. So I can write it as probability of this lying between mi to mi plus 1, and it is representing the area from mi to mi plus 1 fx of x dx, and this is the area of the region I. So this is your general formula. Now we can see two variations here. If PDF is uniform, then delta I can have any size. There is no restriction on the size, and this particular value can be written as fi into delta I, because if the amplitude of the PDF will constant, it will always make a rectangular strip, and the area of the rectangular strip can be written easily. Similarly, if we consider PDF to be non-uniform, then if delta is very small, then the amplitude can be considered as constant. Then this integration can be written as fi delta I. So this is the general integration. You can approximate this integration based upon the two cases. If PDF is uniform, then delta I can have any size, and if PDF is non-uniform, then delta I has to be very small in order to write this expression as fi into delta I, or in order to consider it as a rectangular strip. Now let us try to have another relation which is also very important. So this was the PDF of the x, or the variable which is present at the input of the quantizer. So this is the PDF of the random variable. This value will become m1. This is ml plus 1. Here we have mi plus 1. Width of this region is delta I. Similarly, you can define different regions based upon the decision thresholds. So these are the regions based upon the decision thresholds. This is delta 1, this is delta 2, and these are the areas. So let me call this area as AI. Let me call this area as A1, this area as A2, and this particular area as AL. Now we know that if I have to calculate the area of the region I, so I can calculate the area from mi to mi plus 1 fx of x dx. So this will give me the value of ai. Now if I integrate this value from 1 to L, which means if I consider this integration from mi to mi plus 1, so we will get the area of this particular region AI. Now if I sum all these areas, or I can write it as I equal to 1 to L AI. So it will give me the summation of all the areas A1 plus A2 plus AI plus AL, and this will be 1. So this integration is also very important, that if you have considered the area of any particular region, and if you want to integrate or you want to combine all the areas, then obviously the sum of all the areas are going to be 1. So this particular expression sometimes we will encounter, and you must be able to understand it. What does it mean? So it is meaning that first of all I have calculated the area from mi plus 1, sorry, mi to mi plus 1, and then I varied this I to 1 to L so that all the regions are covered and we can get the overall area of the PDF. Now let us calculate the quantization error power. So we have defined that quantization error power can be written as expectation of x square QE, or you can write it as expectation of x minus x cap square. So it will become x minus x cap square PDF of continuous random variable x into dx. Now this can be also written as from x min to x max x minus x cap whole square fx dx, or expectation of x square QE can be written as m1 to ml plus 1 x minus x cap square fx of x dx. So we know that whenever x is varying between m1 to m2, the x cap becomes x1 cap. Similarly, if x is varying between mi to mi plus 1, x cap becomes xi cap, or when it varies from ml to ml plus 1, it becomes xl cap. So if I am taking the limit from m1 to m2, which is the region R1, so this will remain x, but this x cap becomes x1 cap square fx of x dx. Similarly, if I take the region from m2 to m3, this x remains variable, but this x1 cap becomes fixed, and it can be written as x2 cap square fx of x dx. Similarly, when this varies from mi to mi plus 1, it becomes x minus xi cap whole square fx of x dx, plus when I will consider the L region, which is ml to ml plus 1, this x will remain variable, but this xl cap becomes constant, and it will become xl square fx of x dx. Now expectation of x square QE can be also written something like this, that first of all we will integrate from mi to mi plus 1, and this will become xi minus xi cap whole square, whatever may be the value of PDF in this range. And instead of writing all these values, I can just write a summation from I to L, and this will cover the formula for quantization error power, or you can also call it as quantization noise power. So you can call it as quantization error power or quantization noise power. So this is the most general formula which you can remember. Now I can modify this formula also like this, that if I consider the formula is quantization error power is I equal to 1 to L and here it is varying from mi to mi plus 1, and I can write it as xi minus xi cap whole square fx of x dx. So this formula is important, and this is the general formula which you can use anywhere. Now let us try to approximate this formula in order to obtain the approximated quantization error power. So for that I am making two assumptions. First one is, if PDF of x is uniform, PDF of x is uniform, in this case delta can have any size. So this scenario looks something like this. This is the PDF of x, and PDF is set to be constant. So I'm assuming this PDF to be uniform. Now, this can be x min, this is x max. This will be equal to m1, this will be equal to ml plus 1. Now we will take different regions, m1, m2, m3, mi, mi plus 1. So this will be delta I, and this value will be fi. So in this case the value of PDF which is changing with x can be considered as constant or independent of x. Similarly, in the second case, if PDF of x is non-uniform plus delta I is very small. So let us understand the scenario in this case. So it will become something like this. So it will be graphically like this. So here also, if you will see this mi and this mi plus 1 to be very close, so that this delta I is very small. In this case also you can approximately assume this fi to be constant, or the PDF f of x equal to fi to be constant. So this is very important observation for the approximate error calculation. So for approximate error calculation, approximate quantization error calculation, we are assuming fx of x is independent of x or equal to fi, or which is equal to constant. And it can happen in two cases. First one is if PDF of x is uniform plus size of delta does not matter. So delta I can have any size. Similarly, if PDF of x is non-uniform, in this case delta I has to be very small. So we have taken these two assumptions. So this formula, which was I equal to 1 to L mi to mi plus 1 x minus xi cap square fx of x dx can be written as I equal to 1 to L. I can take this fx of x to be constant, and I am considering that when x is varying from mi to mi plus 1, the PDF fx of x has value as fi. So you can see it from here that we are considering that whenever it is changing from this mi to mi plus 1, the value of the PDF is considered to be fi or fi here also. So value of the PDF is considered to be fi, so I have taken since it is constant, so I have taken it outside the integration. So this is constant and I have to vary from mi to mi plus 1, and this will become xi minus x cube square dx. So this is the second formula which you can remember. In this case, the assumption is that we are taking the PDF to be constant. Now for further approximation, you can assume that let Quantizer maps each region at its midpoint. So this was your Quantizer, and if I specifically talk about the ith region, so this is the ith region, and we are assuming that the Quantizer will map any value in this Ri region at its midpoint. So we know that the height of this particular region is delta I. So if it is mapping it at the midpoint, so xi cap will exactly be at the midpoint. So this and this value will become delta I by 2, delta I by 2. So we are assuming that the Quantizer is mapping this region Ri or the values from mi to mi plus 1 at its midpoint. So the midpoint becomes xi cap and these values will become delta I by 2 and delta I by 2. So from here you can say that this mi plus 1 minus xi cap will comes out to be delta I by 2, and mi minus xi cap will become minus delta I by 2. So the formula that we got till now is expectation of x square QE equal to I equal to 1 to L fi integration from mi to mi plus 1 x minus xi cap square dx. So let us assume, let this x minus xi cap to be z. Now whenever x will be mi, so z will become mi minus xi cap, and you know that mi minus xi cap is nothing but minus delta I by 2. So I can write it as minus delta I by 2. Similarly, if I consider x to be mi plus 1, so this z will become mi plus 1 minus xi cap, or from here you can see that you can consider this mi plus 1 minus xi cap to be plus delta I by 2. So it will become plus delta I by 2, and you can also write dx equal to dz from here, because this xi cap will become constant once this range mi to mi plus 1 has been fixed. So you can write it as sigma I equal to 1 to L, this will become fi. This range becomes from minus delta I by 2 to plus delta I by 2 z square dz. Now let us try to solve this integration. It becomes I equal to 1 to L fi, and it becomes z cube by 3. So I can write it as minus delta I by 2 and delta I by 2. So it becomes I equal to 1 to L fi by 3, and it becomes delta I cube by 8 plus delta I cube by 8. Or I can write it as summation I equal to 1 to n fi delta I cube by 12. So finally we got the formula expectation of x square QE, which is equal to summation of delta I square by 12 into fi, where I is varying from 1 to n. So in this formula we have assumed various assumptions. First assumption is that PDF is constant, and for PDF to be constant we have two different regions. One reason was that fx was uniform, and another reason was fx was non-uniform but delta was very small. And second assumption, we considered that the quantizer is mapping each region at its midpoint. So based upon these two assumptions, we have calculated this value. Now this can also be written as expectation of x square QE summation of I equal to 1 to L. Let me separate this delta I square by 12 and multiply this fi into del I. We know that if fi is constant, then this fi delta I will represent area of region I. So this fi has already been considered as constant, so this will represent the area of the ith region. So it will represent area of the ith region. So this formula becomes x square QE equal to summation of I equal to 1 to L delta I square by 12 into AI. So this is the approximated formula for quantization error calculation. Now let us try to analyze this formula for different cases. For case 1, I am considering PDF of x is uniform. So in this case, we are considering that this x is having uniform PDF. So this will be x min, this will be x max, and this will be 1 upon x max minus x min, or you can also call it as fi. Now the decision thresholds will divide into different regions. So it will become M2, it will become M3, it will become MI plus 1, ML, it will become ML plus 1. So this width will be delta 1, this will be delta 2, this will be delta I, this will be delta L, and these are the points. Similarly, it will be fi, this will be also fi, it will also be fi, Fi and Fi, and the area of this region will be considered as A1, AI. Similarly, area of this region will be considered as A1. So the formula for quantization error was summation of I equal to 1 to L delta I cube by 12 into Fi. This we have written as I equal to 1 to N delta I square by 12 Fi into delta I. Now you can see that this Fi into delta I is representing the area of this region AI. So I can write it as I equal to 1 to L delta I square by 12 into AI. I can expand this, so it will become delta 1 square by 12 into A1, which means this is delta 1, it's a square by 12 into area of this particular region. Similarly, delta 2 square by 12 into A2, which means this delta 2 square and area of this particular region. Similarly, delta I square by 12 into AI into delta L square by 12 into AL. Now if I consider the uniform step size or the uniform quantization. So earlier we considered the PDF to be uniform. Now we are considering the quantization to be uniform or the uniform step size. So in this case, the delta 1, delta 2, delta 3 and so on, it will become equal to delta I equal to delta L equal to delta. So I can take delta square by 12 common from here, and inside I will get A1 plus A2 plus AI plus AL, and we know that it will represent the area of the PDF, and the area of the PDF becomes 1, and the quantization error comes out to be delta square by 12. So whenever PDF is uniform and you have considered uniform step size, in this case the PDF will become something like this. So you can draw two formulas from here. If PDF of X is uniformly distributed, so you can two formulas for quantization error. In first case, if delta is uniform or constant, or we can also call it as uniform quantization. So in this case, expectation of x square QE or quantization error comes out to be delta square by 12. Similarly, if delta is non-uniform or variable or non-uniform quantization, which means the width of each region is different, so it becomes non-uniform quantization. In this case, the quantization error can be written as delta 1 square by 12 into A1 plus delta 2 square by 12 into A2 plus delta I square by 12 into AI plus delta L square by 12 into AL. You can also comprehend it as delta 1 square by 12 into area of the region in which step size is delta 1 plus delta 2 square by 12 into area of the region in which step size is delta 2 and so on. So this you can extend on your own. Now let us consider the second case. In this case, we are considering that PDF of X is non-uniformly distributed. So it is non-uniformly distributed, or you can consider it like this. This is the PDF, and let me show the distribution. So this will be the distribution X min to X max, or again from M1 to M2 to M3 to Mi plus 1, and this is ML plus 1, this is ML. Again, the width of this region will be delta 1, this will be delta 2, this will be delta I. Since all the deltas has been considered to be very small, so this will be F1, this will be some F2, this will be some Fi, and this length can be considered as Fl. Now the quantization error that we obtained was summation of I equal to 1 to L delta I square by 12 into area of ith region, and area of ith region means this area, all these areas which are shown here. So this you can call it as A1, this as A2, this as AI, and this area as AL. So these are the different areas. Now here we can write it as delta 1 square by 12 into A1 plus delta 2 by square into A2 plus delta I square by 12 into AI plus delta L square by 12 into AL. So these are the areas of the different region. Now again, if I assume let delta is constant, which is representing the uniform quantization or the uniform step size. So in that case, you can again write delta square by 12 into A1 plus delta square by 12 into A2 plus delta square by 12 into AI plus delta square by 12 into AL. So I can take delta square by 12 common, and inside I will get the summation of all the areas, and the summation of all the areas represent the area of the PDF, and it comes out to be 1. So here also you can divide it into two parts. If PDF of X is non uniformly distributed, if delta is constant or uniform quantization, in that case the quantization error power will be delta square by 12. And if delta is variable or case of non-uniform quantization, in that case you can write it as delta 1 square by 12 into A1 plus delta 2 by square into A2 plus delta 2 square into AI plus delta L square by 12 into AL. Or alternatively you can also write it as delta 1 square by 12 into area of the region in which step size is delta 1 plus delta 2 square by 12 into area of the region in which step size is delta 2, and so on. So the formulas of the quantization error: power, quantization error, power, can be summarized in following ways. So the most general formula without any approximation or assumption should be this: minus infinite to infinite x minus x cap square fx of x dx, and you can write it as from x min to x max x minus x cap square fx of x dx, or can be written as from m1 to ml plus 1 x minus x cap square pdf dx. So this is the first formula. The second formula can be written as expectation of x square QE, and it is the modification of this particular formula, which is I equal to 1 to L x minus xi cap whole square fx of x. This is mi to mi plus 1 dx, and now you should vary I from 1 to L. So this is the second formula. In the third formula, you can apply the approximation that fx of x is constant in each region. So for each value of delta I, f of x is considered to be constant, and quantizer maps the region at its midpoint. So if PDF is constant in each region, the constant value need not to be equal, but the PDF must be constant in each region. For example, for region R1, the PDF may be F1, but it is constant, not the function of X. For region R2, the PDF value should be constant, it might be F2. For region Ri, the value of PDF must be Fi, it must be constant. For region RL, the value of PDF must be FL, it must be constant. So in each region it must be constant, but it need not to be equal with each other. So it may not be equal with each other, but it should be constant, and it should not be the function of X. So the formula modifies in this case. Expectation of x square QE comes out to be summation of I equal to 1 to L Fi into delta I cube by 12, or you can also write it as x square QE equal to summation of I equal to 1 to L delta I square by 12 into Fi delta I, and this can be also written as I equal to 1 to L delta I square by 12 into Ai. So these are the formulas which we should remember based upon the different given conditions. Now, procedure to apply formulas in the given problem. So first of all, what you should identify the PDF at the input of the quantizer plus if quantizer is mapping the region at midpoint, then you should identify if PDF is uniform, then delta can have any size. So the size of delta can be any size, the size is not a problem. And if delta is fixed or constant, or it is the case of uniform quantization, in that case the quantization error power, which I am denoting as PQE from now onwards, will become delta square by 12. And if delta is variable, then the quantization error power will become delta 1 square by 12 into area of PDF in which step size is delta 1 plus delta 2 square by 12 into area of PDF in which step size is delta 2 and so on. So this is the case. Now if PDF comes out to be non-uniform, PDF comes out to be non-uniform. In this case, and size of delta is very small. So here also you can apply these two formulas. If the size of delta is very small and that too delta is constant, then the quantization error power will become delta square by 12. And if delta is variable, which means it is the case of non-uniform quantization, then again you can write the formula delta 1 square by 12 into area of PDF in which step size is delta 1 plus delta 2 square by 12 into area of PDF in which step size is delta 2 and so on. So here also we got two cases. Now next onwards, if PDF is non-uniform and delta is not sufficiently small, or you can say delta is large, so in that case you should use the general formula, which is x square QE expectation of x minus x cap whole square, and it comes out to be summation of I equal to 1 to L mi to mi plus 1 x minus xi cap का whole square fx x of x dx.
So hopefully we have understood every concept in this class. If you have any doubt in any concept, you can let me know in the comment section. I'll try to resolve that thing. Apart from that, you can also follow me on various social media platforms. For example, you can join this Telegram group where you will be getting important notification, important updates. This is Telegram group where you can also comment, you can ask your queries, or maybe you can also suggest me for the improvement. Apart from that, this is my Unacademy profile. On this Unacademy profile, you should also follow me so that you can get the important updates of the Unacademy also, right? And this is the Notion page. You just have to type this tiny.cc/ Vishal Gate. So you will be redirected to a page where all the special classes are arranged very systematically. तो मैंने बहुत सारे टॉपिक्स पे स्पेशल क्लास ले रखी है. फॉर एग्जाम्पल नाइक्विस्ट, Fourier series, latches and flip flop, double integrations. Okay, lot of things are there. So you will be getting all these concepts absolutely free of cost. You just have to type this in your URL. You will be redirected to that page and attend these lectures one by one. You will be getting a next level confidence in these topics that I can guarantee you. Now this is the Notion page of your YouTube, on which you will be getting the links of the YouTube. Apart from that, you will be also getting the PDFs of that particular lecture. So this is very important for you, and just you have to type http://bit.ly/GateLive. So GateLive, you just have to type it in the capital so that you can access all the lectures link and PDF arranged systematically. So if you want to attend or you want to clear the examination with the free resource, then this is the channel for you. This is the best recorded videos which has been ever made. You just have to go to that lecture, just click the link and download the PDF and start studying systematically. So we have also done this for you so that any student, whether he is sitting any part of this country, should not face the difficulty in cracking the examination, whether he can afford or he cannot. Now if you can afford, then the subscription prices are not something which you cannot pay. It is very nominal amount which you can pay, and you can just avoid all the distractions, all the time wastage which we will be doing in downloading those PDFs, arranging them, arranging for the test series, and a lot of other things that you have to arrange, doubt solvings you have to arrange by yourself. If you want to avoid all those distractions in a very nominal amount, so you can go for the Unacademy Plus subscription. For 12-month subscription, you have to pay only 74 rupees per day. Apart from that, for 18-month subscription, which is the best possible subscription, you have to pay 63 rupees per day. It is even lesser than the pizzas that you order on your home. So it is that much of amount that can shape your career, that can give you the best possible rank in the examinations under the guidance of the best teachers of the country, which has been right now placed on the Unacademy. Now 24-month subscription will cost you 54 rupees per day. So these subscription amounts will give you the subscription for the desired period. Apart from that, if you are using this code, you just have to remember this code, write my name, write GATE after it. You can also write ESE after it. So you have to write my name and write ESE after it. So any one of these code, once you apply, you will be immediately getting the 10% discount. You will be getting all the features of the Unacademy. You will be getting the guidance of all the teachers present on Unacademy, and everything you will be getting that is needed to crack the examination once you are using this code. So if you think we are working hard, we are giving our best content, we are giving the free content absolutely for you guys, and everything that is needed for every student to crack the examination. So never forget to use this code whenever you are taking the subscription. So this code is very important and you have to use every time you are taking the subscription. Now those who are interested for the prices, total price amount, so let me tell you, total price is 27,225 for 12 month, 34,650 for 18, and for 24 month it is 39,600. You can also pay this by using zero cost EMI. Zero cost EMI can be paid by credit card and debit card. In debit cards, there are only Bajaj and HDFC as of now available. Okay, so the zero cost EMI means you do not have to pay anything extra. Any interest is not, you should not pay, and you have to pay this much of amount on the daily basis if you are looking for the zero cost EMI option. Apart from that, if you are coming for Iconic subscription, so Iconic mein, I have already told you that your personal coach will be the game changer. He will be he will be basically following you to give you the guidance so that you can get the success in a very short span of time. So he will be following you, he will be pushing you every time. Now once you use this coupon code, this will be costing you around 45,225, and if you are using this coupon code, write my name, GATE after it, you will be getting the 24-month subscription of Iconic in 66,600 rupees. Fine. Apart from that, every one of you should follow this GATE aspirant group, and there also some important notification always comes. Now what are the YouTube channels that you should immediately subscribe? This Kreatryx, this is the channel on which you are present. This is Unacademy GATE questions, where previous year questions has been solved by the educators. So you'll be getting all the previous year questions video solution apart from the PDF also. This is the Electrical Junction channel, where you will be getting the important concepts of ECE and electrical, and this is Engineering Pathshala, where you will be getting some practical aspect of the videos, some animated videos that will enhance your ability to think. So these are the channels which you should immediately subscribe so that you can get a better content. Fine. Now these are my some YouTube videos which I have created for you. In all of these videos will give you some motivation, guidance, content, and some strategy. So these are hand-picked videos. You can immediately follow these videos. Okay, so thank you so much. And those who are coming on this channel, immediately share all the content which is present on this channel. We are working very hard for you guys, so this is your responsibility that you should share this channel, you should subscribe this channel, also share the link of this channel, link of the videos, link of the educator whom you follow, so that every student who is needy, they can come onto this channel and they can get the best possible rank. So all the best everyone, let's crack it.